Hi, my name's Alan Smith from cloudcast.net, and this is a webcast looking at atomic transactions within BizTalk server orchestrations, just looking at the atomic transaction shape and seeing how we can use it. So it's going to be level 300. I'm assuming you know a bit about orchestrations, sending, receiving messages, that type of stuff. I'm going to look at when to use an atomic transaction. There's only 3 scenarios that I can think of, but if you can think of any better ones, drop me an email, contact me, because I'd be interested to know about this. We're going to look at the effects on persistence, some of the properties of atomic transactions, and we're going to look at the effects of rollback. What happens to orchestration variables when an atomic transaction fails? So, before we start building orchestrations using transactions, we'll do a quick quiz. Now, this which is faster quiz, you may have seen it before, but bear with me if you have, because there are a few twists that we can do on this. So I'll show you these 3 orchestration designs. This is orchestration A, where we're just receiving a message and we've got 5 sends in a row. Now when you see this on slide decks when they've been doing this quiz on courses and in various presentations, they just have 2 send shapes there. But in order to see the actual difference in the orchestrations that we're running, I've actually placed 5 in there, so the differences will be a bit more marked. So this is a regular orchestration. It's got its transaction type set to none. And we've got a receiver message, and we're basically sending exactly the same message 5 times out to this send port, and I'm using the file adapter for all the communications here. Orchestration B, it looks very similar, but what I've done is I've actually set the transaction type of the orchestration to a long-running transaction, and I'm using an atomic scope here. This is set to an atomic transaction. It's a scope shape, and I've got 1, 2, 3, 4, 5 sends, exactly the same number, within that atomic scope shape. Orchestration C, exactly the same functionality but a different design. I'm receiving a message here and I've got 1, 2, 3, 4, 5 sends in the actual parallel action shape within the orchestration there. So think about which is going to be the faster design. Now if you have seen this before, quite a few people have seen it before, you probably remember what the answer is. So another teaser, think about which could be the faster design if we could make modifications to the orchestration there. And there are slight changes that we can make that can really improve the performance of one of the designs, and that hasn't been seen publicly that much before. Okay, so the atomic transaction shape, what I'm going to do is just to add a new item here, drop on a new orchestration, and we can start to play around a bit with the transaction shapes and see how they work. So I normally work by dropping the insert shapes on here instead of using the toolbar. I find it quicker and it takes up less screen area because you have the toolbar present. And I'm going to drop on a scope shape, and we immediately get this warning here telling us that we have not defined our transaction here. And we've got 3 choices. It can either be a long-running scope, it can be an atomic scope, or it can be non-transactional. And I'm going to choose that it's going to be atomic here. Now there's various rules about transactions there. So a non-transactional orchestration cannot contain any other transactions. That's one of the first rules that we've got about transactions. So I'm actually going to start to put this in the actual slide deck so we can build up a list of these rules. So first rule of transactions, a non-transactional orchestration cannot contain any other transactions. So let's think about how we can fix this problem. Now my actual orchestration is non-transactional. The transaction type there is set to none. And I've got 3 choices. It can be non-transactional, it can be long-running, or it can be atomic. Now we typically set this to long-running there, so the actual orchestration will be long-running. And now I do have the option here to set this to be an atomic transaction. So I can mark this as being atomic. So that's there as an atomic scope. Now I could, if I wanted to, drop on another scope shape within inside this atomic transaction. So if I add another scope here, and I attempt here to set the transaction type here to atomic, we get another error which is popping up a compiler, another rule of transactions: an atomic transaction cannot contain any other transactions. So, second rule of transactions, an atomic transaction cannot contain any other transactions. That's down to the lowest level, and it kind of makes sense because we want what happens within this atomic transaction to actually take place in sort of one sequential unit, so we can't break it up into any other levels here. Now I can also drop in another scope, and I can actually make this a long-running transaction, and I will name this appropriately. So that's my long-running scope, and I can place my atomic scope within my long-running scope and I can have different levels of atomic scope, so several atomic transactions within those long-running scopes. Now my long-running scope, if I want to, I can add two things. I can add compensation blocks, which we'll look at in another webcast. I can also add exception handlers, so if something goes wrong, I can actually handle the exception here. Atomic scopes, they allow us to add compensation blocks if we want to execute compensation code, but they do not allow us to add exception handlers. The reason we can't have exception handlers is normally in normal code when we do a try block and we reach an exception handler, we assume that some of the code in the try block will have executed and some of it will have failed. Now with the atomic transaction, we actually get a rollback, so if stuff has happened during the actual scope shape and we get something going wrong with the actual scope, it will actually roll back the effect within that atomic transaction, and we'll take a quick look at that in a demo a bit later on. So it doesn't actually make sense to handle an exception within an atomic scope shape. So let's take a look at some of the reasons for using transactions. We're going to return to the quiz here, which runs faster. So make a decision. If you go into the which is faster there, make a decision there, and I've actually got these three guys deployed, and I'm going to just test them. So I've got this set up. I've got A, B, and C, which are three identical messages, and I can place those into this in folder here. And we've basically got some receive locations which are listening for A, B, and C star.xml, and we've got our three orchestrations actually connected to those actual send ports and receive ports. So what I'm going to do is I'm going to test each orchestration 5 times here, and I'm going to do this to give the orchestrations a chance to run sequentially. I'm going to paste these in fairly slowly. And we should have a bunch of documents here, 25 objects in the out folder. I'm going to do the same for orchestration B. And the reason I'm doing this sequentially is we want the orchestration to be running on its own in BizTalk server and not have a bunch of orchestrations running together, because that's going to really affect the results there. So we've now got 50 in the out folder, and I'll do the same thing with orchestration C. And that's the 5th one through, and we should have 75 in the output folder. Now, to actually view the performance statistics there, in BizTalk 2006 and 2006 R2 you'd use the health and activity tracking tool, but I'm just going to go here to tracked service instances, just run this query here, and we've got loads of stuff going on here. I'm actually going to limit this so that the service class is equal to orchestration. Run this again, and you can see that we've got the orchestrations running. We've got the 5 instances of C, 5 instances of B, and 5 instances of A running here. And I should have, if I so I'm going to take the duration and move this up next to the service name there. Okay, that. And we can see the actual durations for these. So orchestration C is like 80, 60, 70, 153, 100. So that's clearly not the winner. Orchestration B is doing a bit better on 30, 20, 40, 30, 40 milliseconds here. And orchestration A, we've got 60, 120, 0, 30, and 90 there. So if we average these out, we can see that it is orchestration B that is coming with the lowest times here, around about sort of averaging probably about 30 milliseconds per execution there. Now that may be, so with Performance Monitor running, I'm going to add a few counters here. Now if you go up here into the actual category section, there's tons of counters for BizTalk server, but you may be wondering how we count BizTalk orchestrations or look at the actual orchestration counters. And they're actually hidden right down at the bottom. There's something called xlang-s orchestrations here. Going back to sort of the history, it's basically the xlang-s is the name of the orchestration engine for BizTalk Server 2004. And they've still got the actual orchestration performance counters stuck down there. So what I'm interested in is things like orchestrations completed, orchestrations created, which we've got on there. I'm going to want orchestrations completed as well, and something which is called persistence points. So we've got those 3 counters added here. What I'm going to do is I'll just basically clear out the output directory there, and I'm going to take the orchestration A and just run that with a test message and see what happens in performance. And if I click on the highlighter, you can see that we've got one orchestration created, one orchestration completed, and we've got 5 persistence points for orchestration A. Now, a persistence point is when the orchestration saves its state down to the message box database, and it does that after every time it actually sends a message here when we're outside of a transactional scope here. Running the next orchestration, if I take orchestration B, I'm going to copy this and drop this guy in there. You can see that we've now got 2 created and 2 completed. And we've now got 7 persistence points, and we started off with 5 and we've now got on to 7. So the orchestration B actually only used 2 persistence points, whereas orchestration A used 5 persistence points. So let's try orchestration C. We were on 7 previously, we've now gone up to 13. So we've actually used 6 persistence points in orchestration C, and we've got 3 created and 3 completed there. So the reason that orchestration B is the fastest design is because it uses less persistence points here, only 2 persistence points, compared with 5 to A and 6 on C. So C was actually the slowest design, and although we've got parallel actions here, it doesn't really run these as on parallel threads, as you may expect. There's lots of talk about parallel programming. Parallel actions can be used to optimize orchestration design, and if you look at the design on optimizing orchestrations, I'm calling 3 web services using parallel actions to receive the response from those web services, and calling the 3 web services in parallel. So for those scenarios, it does give you performance here, but we've not got really any performance gain on this orchestration C. So B is the quickest, and the reason is that typically in BizTalk we persist our orchestrations every time we send a message, so we don't get duplicate messages, and so we get reliable delivery of messages. We get once only delivery from the orchestration to the message box. Now, an atomic scope here, if I just zoom in on this a bit more, within the atomic scope we will only persist the orchestration at the end of the atomic scope. That's the only time we actually save the orchestration state down to the message box database. So by placing all of these sends within this atomic scope, we do actually reduce the numbers of persistence points, which increases the orchestration performance. So persistence points is a good thing to track if you're interested in orchestration performance there. Now, I said there was a twist to this question if you've seen all this stuff before. You saw that we've got B as being the fastest design. But I can do a simple optimization to one of the other orchestrations and make that run a lot faster than orchestration B here. So although in my scenario B is the fastest solution out of the 3, it's not the most optimal design that we can get. So think about how we can make a faster orchestration there. I'll run through some more stuff on transactions, and we'll just round off by looking at how we can make a much faster design by modifying one of the other orchestrations there. Okay, so we've seen sort of the first scenario for using an atomic transaction. We can place multiple sends or even multiple start orchestration shapes in an atomic scope, and we reduce the number of persistence points that we get here. Now, back to my orchestration here. What I'm going to do is show you a second use for atomic transactions. Now, if you're working with orchestration variables, you can drop on a new variable, set it to something like a string here, drop that on as string var, do a build, and we get a successful build of the orchestration. Now, if you're wanting to play around with XML, you may say, well, I'll drop on a variable, I'll set it as a .NET class, I'm going to go into System XML, and I'm going to choose the XML node, which you may want to be using if you're basically modifying some of the actual messages or manipulating the content of the messages there. So this will be XML node var. So basically we've got this build error coming up. A non-serializable object type of a node can only be declared within an atomic scope or service. So that's another rule on transactions there. Non-serializable objects can only be declared within an atomic scope or service. Now basically non-serializable, it means that the XML node does not have any functionality. It's not serializable. We can't store its state into the message box database. And that means that because of that, the orchestration cannot persist and it cannot dehydrate to the message box database. So the compiler basically complains and says we can't do that, we can't have this as an actual orchestration variable. So, second use of an atomic scope shape. So I can drop on a scope shape. I can declare it as atomic, name it as atomic, and the atomic scope shape actually has its own variables section. I can move my XML node variable actually into the atomic transaction scope here as an atomic transaction variable, so it's only being used within this atomic transaction. It's building successfully now because the orchestration is never going to persist, never going to dehydrate within this atomic scope shape here, and the XML node variable here is only going to be active within this atomic scope there. So if you want to use non-serializable classes and generate objects of them, you have to do that with an atomic scope. There's one exception to this rule. If I drop on a new variable, go in here, I'm going to select a .NET class, down into the XML namespace again, and I'm going to choose an XML document. Now, if you've done a lot of .NET programming, you probably know that the XML document itself is not serializable. It's very, very similar to the XML node. But there's a common scenario that people might want to use an XML document in their orchestration. So within the orchestration engine, there is actually a mechanism that will take XML documents, serialize them for you, store them into the message box database, and deserialize them. So they've built this actual serialization mechanism. So as far as I know, the XML document is the only non-serializable object that you can generate within a non-transactional scope. So there is just that one exception to that rule there. So we've now got two reasons about using an atomic scope. When do we need to use it? Reducing persistence in orchestrations and increasing performance, and creating non-serializable objects. So far, those are probably the most two common scenarios for using the atomic scope, and none of them have anything to do with actual transactions in business processes, really. The third scenario for using an atomic scope within an orchestration is making calls to transactional components. So this can be COM+ components. I think that I've not tested it. It can even be web services using the WS atomic transaction protocol. But you have to use an inline send here. You can't go through the regular send port and receive port server architecture. And we'll have a look at that in a demo later on. So if you do want to use the atomic transaction for actual transactions within your orchestration, and you have some transactional components that you can call from the orchestration, you will need to call them in line from the expression shape within the orchestration. And those transactional components will take part in the same transaction that the orchestration is using. So this is what I tried to do when I was first learning BizTalk. I was trying to call an actual store procedure on the database from an atomic transaction within an orchestration. I kind of wanted to do some transactional database access and thought, well, this is a cool design. We'll take in a message, we'll do a send and receive, make a call to this store procedure, and be able to actually make that call. Now, if I try to actually build this, we get a build failed, and if we look at the actual output message here, we get another rule on transactions. So I'm going to go to my transactional rules here and paste in this guy. So what the orchestration is complaining about is saying an atomic scope may not contain or call a service or scope that contains both the send and the corresponding receive of a request-response operation on a user's port or service link. Now, it is quite a confusing error message, but it is quite a simple problem within the orchestration. If we think about what happens when sending messages within the atomic scope, so we do this to reduce persistence. If we have, like I had in orchestration B, 5 messages here within my atomic scope. Now what happens is when the actual scope completes, when this transaction completes, the orchestration will persist, and all 5 of these messages are sent into the message box database in one operation at the actual commit point of this transaction, so that is down here. So if I look at my orchestration here, this message is just the same. It will not get published into the message box database until we actually commit this atomic scope, until we reach this point in the orchestration. Now, we can't reach this point in the orchestration until this receive shape has been executed here. So we've basically got a deadlock situation. We're not actually going to send the message, it's not going to be committed until we get down here, and we can't get down here until we receive the message, and we can't receive the message until we've actually sent this message, it's gone into the message box database, and we've got the response that has come back here. So it's basically automatically going to create a deadlock in my orchestration, and that's why the compiler message is failing and giving us this sort of fairly confusing error message here. It basically means we can't do these request response operations from an atomic scope because of the way that the transactions work with the orchestration engine. This transaction will only include the message box database. It will not include any of the other systems there. So if I did want to make that call out to a database call or store procedure, I'd have to do inline code, and I would have to use a transactional component to make that call. And then I would just do that from within an expression shape. And it would allow me to do that. That would compile successfully. Okay, so just to show you a bit about what happens to orchestration variables in atomic transactions. And I've built up this quick orchestration very, very simple. It's actually triggered just by a message coming in. And I don't do anything with this message. All I'm doing is working with some orchestration variables. I've basically got a couple of these in my orchestration, a string variable and an integer variable. Now when I start the orchestration, I basically set the string variable to have the value of hello, and then I've got this debug shape, and the debug shape is just printing out the value of this string variable out here, and so we can actually see it in the debug window. And I'm actually using debug view, great tool from sysinternals, to actually view the debugging information from the orchestration there. Now what I'm doing is I'm basically going inside this atomic transaction shape here. And what I'm doing here in the world shape is adding the value of world to this var string here. So we basically set it to hello world. And then I've got another one of these debug shapes where I'm printing out the value of var string, which should, of course, have the value of hello world here because we've built up that string with those two words. Now here, I've got a shape that's forcing a divide by zero error. Var int is an integer variable I have set to 0. And I'm just forcing the orchestration here to generate this divide by zero error. So we will generate an exception. Now you cannot add an exception handler to an atomic scope. So what I've done is I've placed this atomic scope within another long-running transactional scope here. And I've got my exception handler down here, and I'm catching the exception here. And what I do here is I just basically print out that an exception has occurred, ex.message. And in the catch block, I'm just using a standard system exception here, so I'm not explicitly catching for a divide by zero exception. Now, good question. Now, what happens here? I'm going to print out the value of var string here. So the execution of my orchestration, we go in here, we set the string to hello, we print it out to the debug window, go into the atomic scope, set the value, add world on, so the string has a value hello world, then print that out to the debug window, then divide by zero, and we'll jump out of the atomic scope shape there. That will fail, so we'll throw an exception out of the atomic scope, down into the exception handler, and we're printing out the value of var string here. So I'm going to run this as a test here. What I'm going to do, I've just got it hooked up to semport A, so I'm going to copy this guy and drop this in here. And go to debug view. And you can see what's happened here. In the start of my orchestration, we set the value to hello, and that was expected here. And we then got to the point where the string was equal to hello world here. And in the orchestration, this is this point here, where I actually do the debug after setting it to world. And then we get the exception occurring, and we jump down here into the exception handler here, and into this debug shape. Now here, you can see the exception is saying attempted to divide by zero, and the actual value of var string is equal to hello, and not hello world. Now this is an important thing about what happens to orchestration variables in atomic scopes, because something has gone wrong in my atomic transaction here when I divided by zero. One of the things I did in my atomic transaction here was to add the value of world to the actual string here. But because this has failed, the rule is, if we can't do everything within this atomic scope, then we're going to roll back and forget all the changes that we've made. Because this failed, we're actually rolling back the value of my var string, so it has its original value when it went into this atomic scope shape. And that's why, when we get down here, the actual value of that string is just equal to hello, and not hello world there. So bear that in mind when you are playing around with atomic transactions and building projects based on them, that the variables will, if something goes wrong here, actually drop back. And this can drive you crazy if you're trying to debug something and you're not aware of that, because variables are turning out with different values from what they may seem. So when I actually do debug write line, it is not transactional, so it will come out in the debug window here. Now if I was using a transactional component to log to a data store, that would not have taken place until the actual transaction committed, so we would not see this hello world appearing here if I was calling transactional code in my expression shape here, instead of actually going out to system diagnostics debug.write. So a couple of tips here. Be aware of this, understand what happens to these variables, and also this in combination with the debug view. This is a great way of seeing and just debugging what's going on in the orchestrations. Don't need to attach the debugger to the orchestration process there. Okay, so back to that question I left you with halfway through the webcast about which of these orchestrations can be the fastest if we make changes. So I've made a modification here to one of these orchestrations, and I'm going to run the perf testing again, our performance testing, and just see which one is running fastest now. So going into my out directory, I'm just going to delete these guys. Going to my docs, I'm going to take A and run through 5 of these. Go for the same with B. And the reason I'm doing 5 is, sometimes you can get sort of small variations in the execution time, and we just want to see the overall execution time for sort of 5 of these events here. So I'm going to do the same thing for C. So I'm going to go in here and just run this on the tracked service orchestrations again and just see what the results are. Well, C is on 70, 60, 80, 173, still pretty slow. B is on 20, 20, 40 and 80. And orchestration A, well, 163 the first time, that's probably loading in the GAC, and it's 0, 0, 0, 0. Bit strange that. What I'm going to do is just run a couple of A's again, just copy this guy, and I'm going to look at the actual performance count for A as well, a number of persistence points that we're getting, and I'll just go in and I'm going to actually restart my host instance here, just so we drop the performance counters back to 0. Click on this, and if you remember previously orchestration A was doing 5 persistence points and B was 2 persistence points. I'm going to paste in run orchestration A. Going to the performance, we've got 1 created, 1 completed, and we've got 1 persistence point. So basically orchestration A is now down to just executing with 1 persistence point here. You can see we've run 3 of them, we've got 3 persistence points, and just back into the tracking and track service instances. You can see that it's 0 and 10 milliseconds here. This was just one of the load ones, but if I run a few more out of A, just pasting these guys in here. Zero, 30, 0 and 10 there. Fantastic execution time. So the reason, I don't know if any of you got it, it's quite tricky. I've actually set the transaction type of the entire orchestration here to be atomic. So what's happening here is here we do have a couple of persistence points, 1 for this atomic scope and 1 for the orchestration itself. But making the entire orchestration an atomic transaction, I'm still doing all my sends within an atomic scope. But I've reduced persistence because I've only got 1 transaction point instead of 2 transaction points. Now, it may not be a good idea to make your orchestrations all atomic transactions. You obviously can't do any request response operations, but it is a way of really increasing the performance of the actual transactions. So, a review of these rules for atomic transactions. An atomic transaction can't contain any other transactions. It's the lowest level of transactions in the transaction hierarchy. Long-running transactions can contain other atomic transactions, and you need a long-running transaction to actually specify atomic transactions. First rule, I'm not doing these in order, sorry. Non-transactional orchestration cannot contain any other transactions, so you need to make your orchestration a long-running transaction if you're going to include any sub-transactions within that orchestration. Non-serializable objects can only be declared within an atomic scope or service. That's meaning that your orchestration needs to be an atomic transaction, or you need an atomic scope to actually declare those non-serializable objects. There is one exception to that rule, and that is the XML document, because it's used very often within orchestrations there. They have actually added code in that within the orchestration engine to explicitly serialize that, but it's only the XML document as far as I'm aware of that. You cannot call a two-way operation from within an atomic transaction. That would generate a deadlock, and the orchestration compiler tells you that in a fairly cryptic way. But what it's really meaning is that, you know, this will generate a deadlock. We're not going to allow you to use that. Quick summary, only 3 reasons to use an atomic transaction I can think of, and I'd love to hear of more if you can think of another one. Reducing persistence, placing these multiple sends in an atomic transaction will mean your orchestration makes less persistence points, and it's also a bit more reliable because it will either send out the messages to all the systems, or it will send out 0 messages, so you get a bit more consistency there. Creating non-serializable objects, as we've seen with the XML node, that can only be created within a within an atomic transactional orchestration or an atomic transaction scope there. And calling transactional components, I'd love to do this as a demo when I get it set up as a second webcast to look at transactional inline sends, and I plan to do that if I get time, so watch out for that one. Remember the effects of atomic transaction on orchestration variables. If the atomic transaction fails, it will roll back all the modifications that you've made to that actual variable. So if you're setting a variable to do various things in that atomic transaction and something goes wrong, it will be back to the value that it had before that atomic transaction started. And that can drive you crazy if you're not aware of it. So if you are debugging, and I find that the most useful tool for debugging orchestrations is not the orchestration debugger in HAT or in the administration console. It's actually this debug view tool. Just do some debug write lines in your orchestration, leave the debug view tool running, and you'll see all the stuff coming out in that debug view window there. Great for debugging orchestrations.